My name is Matthias Karven. Alfred is my co-moderator and he will handle the chat. Alfred Huber is our technical leader, so he's the head of the technician department. So if I have any problems, he will guide me. He will help me a little bit during the presentation. So yes, again, this session today will be about verify, qualify, certify. The requirements for a compliance acceptance test, which we will see later on. So what is the agenda for today? We will cover it into 40 to 50 minutes, I think. So who is Softing IT Networks, who doesn't know us? So the basic of IT cabling, I will mention or talk about. So the different types of measurement types, which is verification, qualification, certification. And last but not least, on the 6th, we will have the right certification, what is to do, what you have to look for. And yeah, it will give us on the last point an overview about the different measurements. So let's start with who is Softing. It's a very short, brief introduction about Softing. Hopefully, most of you know us. If not, so Softing is a holding. We have separate divisions. 3 are here on this slide. So one is the automotive division, which develop and produce diagnostic systems for the automotive industry. On the other hand, on the right one here, on the right one here is the industrial automation sector. So they cover everything around industry 4.0. So former it was more bus oriented. Now it's more becoming Profinet oriented. So it covers everything what happens in the industry for manufacturers to measure and to see what happened in the industrial sector. But mainly we are here, the IT Networks division. IT Networks is a brand new division. We were bought 5 years ago. Former it was the name, it has the same name, sorry, it has a name, Cyber Data. Maybe somebody will recognize this name. So we are focused on test and measurement equipment for local area networks. So everything what is in the house, so what you have to measure in the house for computer networks or cabling infrastructure, we will offer handheld products for that. So nothing what is out of the region or out of the housing or enterprise or the building. We do not do any DSL test or internet testing and so on. Sometimes if you take a look to, or you will see later on, our fiber OTDR, yes, of course, it's also possible to measure wide area networks on fiber optic in a single mode way, as an example. So yes, of course, then we are out of the building, but normally we are in. So we are focused on local area networks. In this case, Softing was founded in 1979. Yes, the headquarters is here in Munich. We are just here in Munich, or to be more correct on that, near Munich. Yes, of course, we have employees, a lot of them, and yes, we're doing some turnover, but you can read it from the slide. So we have several offices all over the world. So we have R&D in Shanghai, in Munich, and partly in Knoxville as well, so in the US. We have some sales offices in London, Paris, Vienna, Milano. So we are worldwide present, and if we are not have our own sales offices, we work through distribution in several countries, and some of you I think will join today this webinar of web seminar. Okay, let's go ahead. What we are doing, so I just mentioned that we are developing and manufacture handheld measurement equipment. So one is our most famous product, which is a Wire Expert, which is a certifier. You will see it later on. Then it goes to the fiber expert to the OTDR. To our newest product, which is the Ethernet Speed Certifier, or we call it Qualifier or Ethernet Speed Certifier. And then it goes to the verifying components like the Cable Master series. We have the LAN Expert, and on the left down, it's one of our new products. Also, it's a Wi-Fi sniffer, where you can analyze the data packets in a Wi-Fi environment, and you can hand it over to the Wireshark software. Maybe some of you will know it. And we have some old products which are still cyber labeled, so which is a tone probe and tone generator. So simple products to take a look at what happened with the cabling. So we have a product. It should be, I'm not sure about that at the moment, but it should be possible to download this catalog in a PDF version on the right hand, which should be under the documents. Yes, okay. So okay, you can download this product. So I just get a sign that that is a fact. Okay, let's go to the technical part of this presentation. And before I start with the differences of all the measurement types or test types, I will go to the basic, which means the ISO OSI Reference Model. Maybe some of you will remember this model. It's a 7-layer model. Hopefully some of you know that. So it starts with a layer 1, which is a physical layer. The interface control, here it will be defined if it is an RJ45 interface or sub-D9 connector or something different. Then it goes to the data link layer, up to the network layer, where the routing becomes important, and then it goes up to the application. So if nobody knows what happens there in the different layers, so I compare it with a telephone call, not a modern one, not a voice over IP call. It's more one which is 100 years ago, I think, was a lady is sitting in the switchboard and connect you with the connectors to the right destination if you want to speak. But it's you can definitely compare it to this phone call, Anno Domini. And you have this physical layer, and if you want to see what happened on the physical layer, so here we have the modulation, the data modulation, because you know if you transfer 1 gigabit, it's not you will not need the 1000 megahertz bandwidth with that, because we're using modulation like the phase amplitude modulation, or a simple one is a NRZ or NRZI modulation, or MLT3 becomes important for 100 megabit transfer. And it also defines the physical layer, which voltage is on which pin, and it generates the bits connecting from one to the other device. So if you connect 2 separate networks on layer 1, you have to use repeaters. So it's not really a modern equipment to connect 2 different networks. It's an old-fashioned one, but they are still there. So if you are doing a connection via the physical layer, via the layer 1, you have to use repeaters. And if we talk about the layer 2, we're talking about the data links, the access layer. Here's a protocol defined, like for Ethernet, it's CSMA CD. Maybe some people which are longer in this business knows token ring or token bus protocols, but they are not any longer existing at the moment. So, and in layer 2, it will be defined the MAC address. The MAC address is unique for every device. So if you have a notebook like I have, or Alfred, it has a MAC address for the Wi-Fi interface or for the RJ45 interface, and it's a unique one. It's once in the world, so the MAC address is really unique. If you connect 2 different networks via layer 2, you have to use bridges. bridges is the old word. At the moment, we talk about layer 2 switches. If you go to Extreme Networks or Cisco and so on, you will have the layer 2 networks. And that brings me then to the network layer. The network layer where is TCP IP defined, especially the IP address is defined. So at the moment we have 2 versions of IP addresses in the field. IP version 4, it's the old one, and version 6 is a new one. It's also doing the routing, and if you connect 2 different networks via layer 3, you can connect different networks. That means you can use a router which you have in your home environment, as an example. Here in Germany, most famous is the Fritzbox. I don't know if you have it in the UK or in Poland or Czech Republic or Sweden or wherever you are located at the moment. But normally you will have a router in your home environment which connects your Wi-Fi to the internet, and that's doing on layer 3. And then it goes up to the application layer. This is this one what you can see right now. This is the application, your email, your browser, and your application you just use. At the moment you use the GoToMeeting application, hopefully. To be more concrete, so normally IP will be done in layer 3 and TCP in layer 4, but this is a small difference, I would say. So, but this ISO OSI reference forgot a very, very important detail, which is, I call it layer 0, which is the cabling. So nobody takes care of the cabling, but you have to take care of the cabling. At least it's at the moment in modern networks, we talk about Cat6a cabling or Class EA cabling, whatever, cables and components in Cat6a. Roughly over 80% of the installation out in the field are Cat6a. What that means, we will hear it later on, definitely, but be in your mind, have in your mind that the layer 0 is so important. If you compare it to 7 floors, you want to build a house with 7 floors, you need definitely a very, very good fundament. Otherwise, maybe this one will break down at the 4th floor. If the fundament is not stable enough, you cannot build every 7 floors. So the cabling is very, very, very important. And how it looks like in the field is like that normally. Yes, of course, it could look like that, but it should look like that. And that it looks like that, we need regularity for this kind of cabling, and that means we need some standards, and we need some principles in cabling standards. And standards are very important for every conversation between cars, between electrical devices, telephones, credit cards, data transfer. So without having standards or to standardize the interfaces between all the different devices, that will not work. So we will not have a problem-free handling that. And to be sure in handling the right cabling, we have several standards. So here I show you the EN 5173 as an example. We also have the international one, which is the ISO IEC 11801. But the important thing, it's a generic cabling systems. It defines the IT infrastructure, what happens there. So, and at the moment we talk about 6 different chapters. That means we start centuries ago, I believe centuries ago, with only one version with the general requirements, but now we have some different chapters for office premises, for industrial premises, becomes more and more important. Homes, of course, yes, we are using little data centers in our homes right now. We have the data center application, which is also a big issue in the market regarding cloud computing. And we have the distributed building systems, so that is in line also with Wi-Fi applications and so on. So we have a European standard, which is written by the CENELEC organization. And if you adapt that European standard to your local country, like we did here in Germany, for instance, then it will be called, it will get 3 more digits on that. We call it then DIN EN 5173. DIN means Deutsche Industrienorm, which is German industrial standard. And normally, the different countries in Europe should adapt this European standard to their local standard. So hopefully it's done in every country in Europe. It should be done. And that's the reason why the EN 5173 is so important for us to get the right cabling premises in the world. So what is written in there? So first of all, it's written in what should I do if I want to connect building A and B and maybe C. So if I have a campus area or something like that. And in the EN 5173 or ISO IEC 11801 is written that I have to use fiber optic cables for that. So I should use single mode cable. I can use multi-mode cable as well, but the preferred cabling should be fiber optic in this case. So and then we have this rising area or riser area, the backbone structure, which should be also preferably with fiber optic cables in the building. You can use multi-mode cables or preferred multi-mode cables. You can also use single mode cables. But the most important thing for us here is, and that's the reason why I have so many devices here in front of me with a certifier, qualifier, and the normal cable tester, are the horizontal cabling, the floor cabling, which is mainly installed with copper cables. And therefore we have the main connectors, numbers of connections, and this is a very important thing we have to think about. So what we forget here again in the standard is, and that is not written, that is added by me, is a Wi-Fi issue, because Wi-Fi is today definitely transmission which you normally use, because the wish of mobility in our work, at home, in our buildings, in the enterprise segment is very high, and Wi-Fi, it's part of the infrastructure, data connection or data transfer infrastructure of a building at the moment, but it's not written in the standard. So in the standard we talk about primary, secondary, and tertiary sectors, and the Wi-Fi is only an addition from my side that you have in your mind. Wi-Fi is also an important thing you have to think about. So what is installed in this horizontal cabling area? We talk about the single component, and my belief is everybody knows that we use a patch panel. Then we have the cabling, the cable, which is Cat6A or 7 cable or whatever, 1000 megahertz cable or 2000 megahertz cable, whatever. And we have the data socket or the data outlet here. And this is exactly that what is fixed with a building structure. That means if you install this one, so it is fixed, installed in the building, you will never, I will not say never, but you will not change that. So in addition to that, what you also need are the patch cables to get the connections from the patch panel, from the outlet to the end device, to the computer, to the router, or whatever. So then it looks like this one. We talk about the, we call it transmission link. The transmission links means you go from the switch, from the router with a patch cable into the distribution panel or patch panel, then via the cable to the socket, and then it goes through the patch cable to the end device. And therefore, you have the transmission installation link. What can be measured here? And that is a question, because on one hand, what we can measure is directly after installation. So directly after installation, because panel, cable, and socket is fixed with the building, so nobody will change anything around this constellation. So normally this is definitely the link which we use for an acceptance test direct after installation. If you have some trouble, because if you connect it with a bad patch cable or something like that, maybe you can get some trouble with getting the right speed to your end device, then you have to take a look for troubleshooting. Then you have to be aware of measuring patch cables here on this end, on the other end, that you have it in your troubleshooting measurement. So you have two different links to measure: the acceptance test, sorry, and the troubleshooting link in this case. So how can we do that? How can we do that? And what should we do first in this case? So the first basic test is definitely to check if the wire map is okay. And how looks the wire map? That's really easy. We have this pair constellation related to the RG45, which means that one pair is built by pin 1 and 2. The next pair is 3, 6, and then it goes to 4, 5, and 7, 8. If you take a look to the ISO IEC 11801 and the EN 5173, so this European standard, it will only show you that you have to use this pair scheme, but it's nothing written about colors or which pair should be connected to which pin. That comes with the EIA and TIA 568, or it's written in the EN 5174. Maybe some of you know this standard, installation standard. We talk about version A, and if you have a version A, you will have a version B as well. So you have two versions to connect your cable to the pins, to the RG45 pins, and what you see, the difference between version A and B is pair 2 and 3, they change the places, which is, yeah, not a huge thing. My belief at the moment, you can say, okay, version A is the advanced one and version B is behind A, but there is no ranking between these two versions. You can use both versions. That's your choice. That's definitely your choice. But please, if you're doing a choice, take the same pin assignment, the same pin or pair scheme in the patch panel side, as well as in the data circuit or socket side. So you have to take the one scheme for the entire building. So if you mix it, you will see something can happen and you can measure that. I will show you it later on. But the important thing is you have the choice between version A and B. And if you get a data socket from, I don't know which vendor, your preferred vendor to deliver patch panels or something like this. Here in Germany, we have a very important vendors like we call it Telegärtner or Metz BTR. They offered it, and normally you can you will have this color scheme, both color schemes on the connection side from the socket. So yeah, please do not do a mix-up on that. Yeah. So before I go to extended to the before I come to the extended measurements, I have to say, first of all, that the EN 5173 it's definitely a standard, and but anyway, if the standard is not part of your contract, it's not automatically mandatory, because you should agree on the standard, or both sides before you're doing an installation should agree if I should install it like a standard installation, like it's written in the EN 5173 or a standardized document. If not, you can do whatever you want in the building, as long as the data goes from one side to the other side, it will be okay. But yes, a standard it's a good paper to take a look or what happened or what I can do. But have in your mind that standards are having very often only recommendations and not really the requirements. And a standard is based on minimum requirements. So the technology could be far in front of what's written in the standard. So that means the actual technology could be much better than the standard. Yeah, let's start with the first test type, which is verifying. You see here some equipment I have, or some devices I have. This is a Cable Master 500. Hopefully you can see that. I have to take a look there. So it's a device where you can measure the pin assignment, the pin scheme. You can see if you have the correct wire map installed. Often you can see what is the length. It's also here the length. What is the length of the cable? And yeah, if everything is okay. You see here the velocity of propagation, which is a percentage, which is mandatory to have the right one here to get the right length of the cable, because we measure the length electrical, not mechanical. And if you send an TDR impulse through the cable, which is roughly 300,000 kilometers per second, and you have some resistance, you have some capacitance, which have influence on the signal and so on. And so if you do not have the right value here, it's called VOP or NVP sometimes, then you will not get the right length. So that's an important value you have to type in. On the other hand, some of the verifying or testing equipment, like the Cable Master 600 or 800 I have here, was a color display here, can also check active connectivities. It can tell you if you have if you are connected to a gigabit Ethernet and in full duplex or whatever, and it can also check if you have a PoE connection or something like that. So let me say the higher valuable verifier can do also this network tests. How looks the test? On one hand, you have this different devices like the Cable Master, and these verification devices are based on DC parameters. That means it can check if you have a cable break, short circuit, crossover, and so on and so on. And if you have a cable break, it could also tell you where the cable break is. That means in which distance is the cable break? Is it in the middle of the cable, or is it at the far end or on the near end? So that can be measured, especially with the Cable Master 600 and 800. It has a TDR function. It can also tell you where the short circuit is. That's not possible with the Cable Master 500 because it has it generates the lens or measures the lens in a capacitance way, and that means it could check where the break is and which distance the break is, but not it cannot detect the distance to a short circuit. That's an important thing. So it can, all these three, or this cable master series can definitely detect the wiring errors. A documentation, a kind of a documentation, not a real documentation, but a kind of a documentation is possible with a cable master 600 or 800. It can doing a simple error analysis. Yeah, the cable master 600, 800, and the 500 can also measure coaxial cables, so it can check if it's a break or the distance. And yeah, as I mentioned before, it has also some PoE or power over Ethernet possibilities to measure that. If I go to a dark distribution room, it will be very helpful if you have a real bright colored display. You can see that because here it's very bright. So, but normally the rooms are dark, and maybe you're under the table or wherever under the desk to check some lines. It makes really sense to have a bright display. Or if you have a device which has a backlight possibility, the Cable Master 200, which is a small one, hopefully you can see that, is not able to has no backlight, so it will be dark in the dark room. So please have it in your mind. That's only in addition to the function of these devices. Yeah, let's go to the Cable Master 500. If everything is okay, and this is an unshielded twisted pair because there's no shield in there, and you can type it in the Cable Master 500. If you're using UTP or SDP cable, you will get a pass or fail check sign, and you have the identifier number 1 means the remote, which is direct in the device, is regular, has the ID 1. It can also show you the meters, the length of the cable, as an example. So if everything is okay, like this one, as you just see here, you will get this yes, well done sign. But if you have some faults in it, as an example here, it's a shortage, short circuit on pair 1 and 2, and it has a break on pin 7 or wire 7. Here it would show you the minus signs just under the 1, 2. That means I have a short circuit here, and here we missed the numbers here, 7, 8. That means it has a break there. So why the entire pair? Because yes, of course, I have only a break on line or wire 7, but this kind of devices can only show you if one line is not connected, it will show you the entire pair is not connected. So that's that depends on the measurement type of this equipment. So that looks like as a Cable Master 500. To compare it with a Cable Master 600, it's you get the same information, roughly the same information. You will get the information that 1 till pin 8 are connected. You have the length here was 60.5 meters, and if you have a fault there, it will also show you that you have a shortage on 1, 2. The graphic is much better, and it's a bright color display as before with the Cable Master 500. So it shows you the shortage or the interruption or the break on 7, 8. So that's happened. That's what the Cable Master series can show you, and that means it can definitely show you if you have a connection or not. If the pin assignment or the pin scheme or the pair scheme is the right one, and yeah, you have a short circuit or something like that. But if you want to transfer something from A to B. And this, in my example here, is it you want to get informed if you have a connection between Hamburg and Munich. Yet, yes, of course, Cable Master will show you, yeah, there is a connection, definitely. And the connection is not, there's no crossover or no crossings in it and so on. And the line is goes from pin 1 to 1 and so on. So there's no break in it. So all the bridges are there. And now you can definitely transfer 1 gig X as an example, so 1 billion X, which brings me to 100 million boxes of 10X. I want to transfer it from Hamburg to Munich with a very, very, very simple technology behind that. And now you have the choice to take a field trail or a highway. So you can do your choice by yourself. What will be the best way to get or to avoid really scrambled eggs? So if you want to transfer these 100 million or 1 billion eggs from one side to the other side, which is a better way for this simple technology? Yes, of course, it will be the highway and not this field trail. So. And the reason why I show you that is the Cable Master series will tell you, yes, there is a connection between Hamburg and Munich, but it will not tell you what is the performance of the connection. And if you want to know about the performance of the connection, you need to qualify your connection or your cabling infrastructure. Qualifying means I can do some speed test up to 10 gig. In case if you're using the NetExpert XG, which is this device here on my left, it will generate a better report as it could be done by the Cable Master 600 or 800, and you have enhanced Ethernet tests possibilities like ping, traceroute, and network discovery, and so on. So what's doing a qualification? So it's doing 3 or 4 tests. So the basic test is definitely to check, do we have a line? Do we have a connection? And no break, no short circuit, and so on and so on. So that's a basic test. And after this is okay, it will start the next test, which is the SNR test, the signal to noise ratio test. That means you have a noise on your cable. You will ever have a noise on your cable. It could be greater or a little bit smaller, but you will have a noise. And the distance between signal to noise is or the ratio between signal to noise is a parameter of the quality of your cabling. The second one, which is done by the NetExpert XG, is he will test if we can transfer 1 gig, 2.5 and 5 gig. It's for Wi-Fi access points or application, or if we can do a 10 gigabit transmission on the cable. That means it will send some data through the line, then it goes to the remote, and then it comes back to the local unit. And if everything is okay with the data, it will say yes, okay, pass. From the sended data, only 0.1% of data can be damaged, and it will be okay. If it is more than 0.1%, it will say no, sorry, it's a failure on it, so it will not pass the test. And the third, fourth test in this one is a delay skew. Years ago, we are using 100 megabit Ethernet. 100 megabit Ethernet users are using 2 pairs, or 1, 2, and 3, 6 was a connection on the pins. As we start with 1 gigabit transmission, we start to use all 4 pairs for the transmission. That means we do not transmit 1 gig over 4 pairs. We transmit 250, 250, 200, so 4 times 250 megabit via the cable. And if the delay is too big in between the cable, because you have here different stranding grades on the twist here, you will see that the signal takes a little bit longer here than here, because the line is the lengths are different in the cable, and if this difference are too high, it's not possible to get the right data again. This is in fact a more important point for unshielded twisted pair cable, because unshielded twisted pair cable they has different strandings on the twist. Here in Germany, and my belief is in Central Europe, we mainly use SFTP cables, so that means pairwise screen cables. So this is not an important one here, so you will not get so often fail on delay skew in this case, so if you're using shielded pairwise shielded twisted pair cables. Yeah, this is more like a summary for you. What the wire experts, the net expert can do for you. A very important point I want to point here, out here is it can also measure PoE++, which is up to 90 watt, Alfred, 90 or 100 watt. Yeah, PoE++, 90 watt. So it can check the actual PoE performance on the line. It has some other, it can identify VLANs, and it can also decode CDP or LDP information, whatever is in the active networks or whatever will be supported by the switch or router. Yeah, we also have a good documentation. Sorry for having this in German language. It's also available in the English language. Yes, of course. You have a possibility to get it out of the device as a PDF document or a CSV file, which you can use in Excel or as a test data. So yeah, that brings me to the third one, to the third test type, which is, yes, the mainly used test type in the field here. We are calling it certification. Certification is definitely the classical acceptance test of networks. It compares to standards. Normally it has some low frequency and high frequency parameters, and it get a protocol which is more detailed, as you have seen it before, because you have this high frequency parameters here, which is the next parameter, return loss, and so on and so on. So what happened with the certification? So certification means we have a measurement, which is here the, I'm sorry for that, which is here the Wire Expert series. It's measuring against standards, and we have a lot of standards available. So we have for cable standards, we have for components, so for patch panels or data sockets. We have for cabling standards, we have for the installation, measurement technology, so that means the accuracy, as an example for an Wire Expert. And on the right hand, that was happened for the Net Expert is the qualification, which is the active network test in line with the IEEE standard. So if you are using a certifier like that, hopefully like that, that it means it will measure against standards which are written in the EN 5173 or in the ISO IEC standard, and it's mainly focused on that one, these two columns which I show you here. So what happens there? So what is written in there? So first of all, we're talking about categories and classes. Categories means we have this single components which are separated into various categories. We call it about category 5 to 6A, 6A, 7, 7A, up to 8 at the moment. And we have these classes. That is, if you are installing all these singular components and doing a cabling and that, we call it then, or we divide it into classes then. So that means, first of all, the categories and the classes are different in which maximum bandwidth you can support with your cabling. And here you see the different standardization organization from the US side, from the international side. This is a European side, Senelec, and yeah, it's a I have the German one in addition to that. But anyway, let's concentrate on the first three, and you will see that the Americans ones, they stopped at 500 megahertz. They stopped at the Cat6A version, and the international guys and the European guys goes up to 1000 megahertz. But have in your mind 500 megahertz bandwidth. Therefore, you can use the RG45 if you are trying to build in cabling infrastructure up to 600 megahertz or to 1000 megahertz, which is the class FA or Cat7A. You have to use different connectors. So that means you have other connectors available, which is the GG45 or the Terra connector. So only the 500 megahertz version supports the RG45. Besides the new one, which is now the 2000 megahertz specification, which goes up to the category 8. You can see it here on the right one. The American goes also with the category 8 infrastructure with the RG45 connectors, and the international and the European one, they split it into two classes. They call it class 1 and class 2, or category 8.1 and 8.2, because the difference is the performance level of 8.1 and 8.2, because 8.2 is again defined with other connectors like we have in the class F or FA environment, and the 8.1 is related to the RG45 again. So it has a less performance on 2000 megahertz, but it works with the RG45, which is an important thing because all the switches and routers comes with the RG45 interface. Yeah, what we will measure with the then with the certifier, yeah, it measures a lot of things: attenuation loss, return loss. It measured some DC resistance, DC parameters, and so on. The pin assignment is a basic, as I mentioned before. And new is that it's also possible to measure DCRU, DC resistance unbalance. That's for becomes more and more important for high power Ethernet transmission in a cabling system. You should. No, not you should. You must use our devices, but there are some other devices on the market, but they are fading out, so they are not any longer interested. It's only to show that we have some other equipment available as well. So, but take the wire expert, and if I take the wire expert, it goes first to the pin assignment. I will only show you what happened with the pin assignment. Is a wire map is okay. It will show you yes. It will show you this beautiful green sign, and that tells you, yeah, everything is okay, go ahead. Yeah, that is if you have a break in a line, and the wire expert is able to detect it wire by wire. If I mentioned before, for the Cable Master series, it will only detect pair by pair. And here, if a break is on a wire, it can definitely, the wire expert can detect it by wire. So definitely pin 6 is a break on that. So then, yeah, short circuit. It will also show you the distance to the short circuit. That's crossing in a pair. You cannot detect where it is. No measurement device in the world can detect that. It can only show you there is a crossing in a pair, but you will not detect the distance to this crossing. This is an A-B mixture. Maybe this is exactly what I mentioned before, that we have this A and B scheme for the RG45, and if you don't use the same scheme in all at all devices, patch panels or sockets, you can get such a result as the AB mixture. Sorry. That split pairs. You know, if you use a data cable, a modern data cable, you have 4 colored wires and you have maybe 4 white wires, and sometimes you're not aware which white one goes, which comes together with which colored, and then you can get a split pair, which is a wrong pairing, and that it will show you. Yeah. Let's go ahead. What's tested by a certifier? It has this low frequency parameters or DC resistance, wire mapped duration, and so on. We have this high frequency parameters like near and crosstalks, or the next parameters, the return loss, the insertion loss, and so on. We have some optional parameters which are new here in this column. And then we have some calculated results, because if we talk about ACR, attenuation to crosstalk ratio, it's a calculation between the crosstalks, the near and crosstalk, and the insertion loss. So it's a calculation. It's not measured. It's defined by a measurement before. That should only give you an overview which parameters are tested by a certifier or must be tested because it's written in the standard. And yes, of course, it's a small summary here. A wire expert or the certifier should be used if you want to be sure that you are compliant to standards, that the performance of the classes you want to support. So if it is a class EA cabling, or maybe a class 1 or class 2 cabling, so which goes then up to 2000 megahertz bandwidth. That's the only way to get this documented and be informed on that, is to use a certifier. There are a lot of certifiers in the field. Forget the red one, because that's electronic wrap. So throw it away or bring it to us. We call it a trade-in program. If you bring back some old device to us, you will get some extra money if you buy a new one from us. So forget the red one. Yeah, you can also forget this red one, and the actual one are on the right side, let me say. The interesting thing is here, and this is unique for softing IT networks, you have a smaller version up to 500 megahertz, and you have the bigger version up to 2500 megahertz, but it looks exactly similar. And the good thing is, the good message on that is, you can upgrade the small one to the bigger one. That's no problem for us. You can send it in. We will replace the measurement board, and then you will get a brand new high-performing Cat6A, sorry, Cat8 measurement device. You can start with a smaller one, with a 500 megahertz version, and then you can go up to the 2500 megahertz version. That's unique. Certifying, yes, I think I mentioned it out before. It's only for you. My belief is also on the right, you can download the PDF version of this presentation. So you will find it in the PDF version. You can see it. And then you can see what happens there. So I talk a lot about copper installation, but it's also on the fiber optic side. We have also this one, this verifying, qualifying and certifying thing. Verifying means it's a visual fault locator. It sends out a red light, and you can see if the connection is there or not, or is a break in the fiber or something like that. For qualifying fiber, you can also use the NetExpert XG in a special version. You can check it up to 10 gig, and you can also measure the attenuation and the length of the fiber. And then it brings you to the certification, which is down here. You can use the wire expert as well. You only have to change the measurement adapter in there to a fiber optic one. We have it in a single mode or in a multi-mode version. And then you can measure it against standards. It's called the tier 1 measurement. And you can also do the tier 2 measurement. Therefore, you have to use the Fiber Expert 5000, which is a classical OTDR. It has also the smart link mapper function in that. So this is called a tier 2 measurement, fiber measurement in this case. So you see what we are doing on the copper side. You can also get it on the fiber optic side. Yeah, this is the way to the right measurement. The specification and performance should be or must be absolutely clear. I think that's an important thing, because the contractor is responsible to clarify the relevant points. By the way, unknowing does not protect from penalties, because if something is written or part of the contract is that you have to use the standard or to define the standard or to measure against standard, then you should know what is in there. Who writes will stay. Believe me, somebody doesn't remember what was a discussion weeks ago. So to be clear on everything, please write it down. And yes, if legally, if it comes to court, that then normally counts the standards, so recognize the standards, what is written in there. So the way to the right certification, it's please inspect the measuring equipment. Tell it your installers. If you are a dealer, please tell it your installer. Tell it the electrical installers and so on. They have to check if the measurement equipment is okay, if the adapter is okay, if the cabling, the measurement cable is okay. Do I have the right adapters? Because on certification we have different adapters available. One is for the channel measurement, one is for the permanent link measurement. Permanent link is that what is fixed to the building. Then create the project. You have to select the data cable, and it will automatically then choose the right NVP, which is the important value for the correct length calculation. Setting the measurement standard. So if you are on the European side, choose the EN, the European standard, which is called EN 5173. You can also choose the ISO 11801. Do not choose, please, the EIA or TIA standard, because it's an American standard. It's not usable here in the European area. Setting the link to be measured, permanent or channel, I mentioned before. Yeah, you have to choose the performance, what you like to have Is it an E performance? So which means the Cat 6 and or EA. I'm sorry, that should be the E should be in capital letters there. So and then press auto test, and if you get a green sign, everything is okay because test is done. If you get a red X on it, that means there is a fault in your cabling infrastructure, and faults could be various in this case. So you could have some near and crosstalk attenuation problems, and this should give you a small overview what could happen if you not getting the brilliant green sign that the auto test is done and everything is okay with your cabling installation. I'm sorry it takes a little bit more time because of the technical problems starting this one, and maybe too many information in it at the moment. It brings me to my last slides. Thank you very much for your attention. If you are still there, yeah, do you have any questions? And I want to invite Alfred to come over here. Maybe he has some questions which pops up during the presentation. Let's start with the questions.
Yes,
we have questions or
yes,
not?
we got a couple of questions
after
we the first wave of questions was just where is the sound?
Okay.
So, but I think we managed that.
Yeah.
Another question.
Sorry for that.
Yeah, happens. Another question was on these high-end verifiers you mentioned, the Cable Master series, the big ones.
Yeah.
Can they also do coax measurement? And I'm not
Yes.
sure how good the camera is. Of course, you can do coax measurements or coax tests, let's say. Yeah. Measure the length.
It's an N-type or F-type. You can measure.
Yeah, there are certain termination tools as well at the end.
Exactly.
It's numbered remotes and so on. Another question was a housekeeping question. Will we record this and share it later? Yes.
Yes, we will do so. Yes, of course.
Yep.
There will be a video available.
Yep.
And if I forget to mention that, that is the first webinar from a series of 5 in summary. The next will be on Thursday. That will be held by you, Alfred.
Yep.
It's about Power with Ethernet. Is it correct?
That's correct. Yeah.
So we will, clarify the situation about Power with Ethernet and how it works and what is important if you are using Power over Ethernet. And then next week on Tuesday and Thursday it will go on with the next one, but I don't know the content. Please take a look on our website. You can see it here. You will get every information on which webinars are also available in the next few weeks.
Yeah. Another question was, you were using these expressions, verify, qualify, certify.
Yeah.
Are these backed up by some standards? Yes, they are backed up by a standard.
Yes, of course, they are.
You know the number?
No, sorry, I'm just getting the number from our global product manager. He mentioned it, I think, one hour ago. But
yeah, it's in the ISO IEC 61935-3.
That's only numbers. Forget the numbers.
So it's defined. There's a definition, a standard definition, standard-based definition for these 3 expressions we are used. Another question I think we got is, I just have to look at the paper here, is on the certification. I think that question you answered later on, it was about the permanent link and the channel link, because you had these 2 different transmission links mentioned.
Yes.
And they are tied to that definition. The permanent link is the installation link.
Correct.
And the channel link is the transmission link, as it's called in the slide. Yes. So I think the guy was missing the expressions just to see that. But you mentioned it in a later slide. You mentioned it.
Yeah,
after I answered it.
I think so. Hopefully it's answered. Yeah. So if not, send me an email. You see my email address there. So
okay, DCRU and POE you also answered before. I think before it came really to market. Okay, if the standard setting were wrong and the NBP value was set wrong on the certifier, do I have to redo all the measurements?
No, because there is PC software available. It's free of charge. and you can doing on the PC software, you can do a recertification. So if you get the wrong MVP, or if you're using the wrong standard, but the standard must be inside the I would say transmission link. So if you have a channel measurement, you can doing a recertification between Cat5, Cat6A, or 6 or 6A. There you can do a recertification, but you cannot do a recertification if you measuring channel, and now you see, oh no, that was wrong because it's a transmission link. I have to measure the permanent link. No, therefore you cannot doing a recertification. It's only in line with the, to measure the permanent link, you can doing a recertification between Cat5, Cat6 or 6A, and you can do it via the PC software. You must not go again to the installation and measure it again. It costs time, and you have to send some people in there. So no, definitely not. You can do a recertification, and if you have choose the wrong MVP, so that the lens is not wrong, maybe too short or too long, you can also adjust that in the PC software.
That's all from the co-pilot.
Okay.
So head pilots, prepare for landing.
Prepare for landing. Yeah, thank you very much for your attention. Hopefully you get some valid information from us. Please, if we stop now the presentation, I think it should pop up some questions to you. It will only take 10 to 15 seconds. Believe me, it's a short, a very short survey for us, that we get some information what we can do better, or what was good, what was not so good, and what maybe we can do better. And please, if you be so kind to fill in this survey. Thank you, Alfred. Thank you to the community out of this room here, and see you next. I will stop the session right now. Thank you very much.